Hey guys, my name is Tomasz Rewak and today I have another project for you. The name of this project is ConsoleGUI and it's a relatively simple .NET application for creating GUI applications within a console. So GUI applications within the console-based applications. The way in which it works is it simply displays the different types of controls as a text. It is a text with changed foreground color and changed background color. And you can see an example here. What's relatively unique about this framework is that it's completely layout driven. So other frameworks that are available in other projects are usually more like, well, if you would compare different frameworks, those are more like Windows forms, where whenever you want to display something, you would just specify an exact coordinates of this control on the screen. And here we have something more like WPF or HTML, when we use containers and panels to actually calculate dynamically the location of each control. So for example, here we have in the background some kind of a stack panel. So we simply specify the list of controls we want to display within it, and it manages the final layout, so how those will be displayed on our screen. And whenever something new appears, all other elements are actually moved up automatically. And we don't have to actually do any special processing there. Of course, this is something that's done by the framework itself. Looking at this example, it's something that should be somehow similar to some kind of a chess game, though of course it doesn't work, so I didn't implement any logic for the game itself. But we can see that here on the left we have some kind of a grid. In the middle we have like some kind of a log file, and on the right we have something that mimics a console. And I can actually type in here, so I can type, oh sorry, I have to focus on this. And if I hit enter, it actually travels as a log line above. And of course, if I type something a little bit longer, it also wraps around and creates another line in which this text is displayed. We can see also here some pop-ups that are in front of everything else, so they they hide what's behind them, even though the content behind them actually updates. So there is some kind of a Z index that tells us which thing is actually in front when it comes to the canvas, at least. And on the left here we can also see, there are some tabs, so I can tap through. And on the second tab we have some kind of a table, and this is the data table. So we just provide a list of data and the column definitions, which specify what is the header, how to extract the data from a row, and also how to apply custom formatting on the row, or rather on a specific cell. And the third tab is some short text here. But you can see that, for example, this board here is actually aligned to the center. Also this text at the top is aligned to the center of this red area. Here we have some elements aligned to the left. We can also align to the right, but I don't think actually that I used this anywhere here. No, it doesn't seem like it. But you can just believe me that it's also possible. And also another thing here is that we have a scroll view actually. So if I scroll up and down, we can see the entirety of the lorem ipsum. So that's a short example of how does the application implemented with this framework actually work. And here now we can actually jump into the code if you are interested in seeing how that thing actually functions. And here we have actually our program. And the thing that we have to do first is to set up everything. Here we can see the example. So first we call the setup function. It's relatively short. One thing, oh, sorry, wrong button. and once again. One thing it does is sets the UTF-8 encoding, though in here we cannot really see this because those pieces should actually be the chess pieces, though in the consoles this character is simply not supported. But if I would change the font, we should definitely see that those are actually the chess pieces. So it's not about the framework, it's about the font that you are using in the console. But let's go back to consoles because it's a little bit nicer to look at. And going back to the code, so this thing, and we also set the buffer size. So when it comes to the consoles or terminals in general, they work in a way that we have a size of a screen and we also have a size of buffer. So it always has to be a little bit bigger or much bigger than the size of a window, because that's how terminals actually support scrolling. So they simply have this huge buffer of characters, and when you scroll, they display a different portion of this buffer. But in our case, we don't want to actually scroll within the window. If we have some scroll bars, those are actually custom controls that will scroll themselves. So in this case, we simply want to actually resize the buffer so that it's of the size of the window. Optionally, we can also set the size of our application. In this case, we are setting this. Also, this is set in the number of characters that are being displayed in rows and columns. So it's not in pixels, and it will also readjust our buffer. But we don't have to do it. If we would actually comment it out, the size of a window would stay the same as the initial size of the window. So if we would have a working console window and we would launch this application, then it would adjust itself to this window size. There is also something called compatibility mode, and it's necessary for consoles like PowerShell. And I'm not talking about PowerShell as the scripting thing, but about PowerShell as the PowerShell.exe. I can show you why, and first of all, maybe I will show you what this thing does. So if I would set it to true, we can see that our application got pretty ugly. And that's because not all of the terminals actually support the true color formatting. And the true color formatting allows us to set the colors of the foreground and background in the RGB. Some controls don't support it. The standard console class within C# and .NET in general does not support it. So we have to use, when using it, few bit numbers. Actually, those are not necessary numbers here in the framework, because those are represented as values from an enum. And when we set the compatibility mode here, whenever something is printed, it will try to get the nearest color to the one specified by us. So the nearest color from this short enum based on the RGB color, so on the full description of the color. There is a short logic to do that. This actually comes from the Stack Overflow, of course. And I can show you how does it work here. So .NET. Yeah, so it looks okay. But if I would stop it and so turn off the compatibility mode, build the application again, and start it within the PowerShell.exe, we can see that it just breaks. And that's because, whenever we print something with the true colors, this is the format that we are actually using. So there is an escape character, there are some magic numbers, and then we provide RGB channels for both foreground and background color, and then at the end comes the content. In this case, the content is a single character. So we can see that the type of this thing is a single char. That's because we are actually printing here character by character. because we don't know actually, we don't get the full string, because it might be that one character will be printed with one background color, but the next character will be printed with a completely different background color. So we have to readjust it constantly. So this is the next step of initialization, and then all we have to do is simply set the content of the console manager, and that's it. The console manager will take care of everything else, of printing this and adjusting its size, etc., etc. And when it comes to the controls themselves, they are relatively simple. Here we have a dock panel, which have some kind of a dock control and a filling control, and a placement for the dock control. And this is all we have to actually specify here. And there, a dock control is another dock control which stores a background, which stores a boundary box. Everyone that designs UIs knows how it goes. Unfortunately, maybe this example is not like very clean by itself, but yeah, you can imagine that this is some kind of a markup language instead of simply C#, and then you get how everything here works. The nice thing about this framework is that you don't have to actually manage any notification between the controls yourself. They will notify their parents about some changes that happen within them automatically. So for example, if you have a text box and you change the volume within it, this text box will notify its parent, and it will travel up to the console manager, and the console manager will redraw it. So you don't have to actually redraw the screen every time something changes within your layout. This is actually quite important thing, because whenever something changes, it doesn't mean that the whole screen will be redrawn. Because for example, if we now start this application, we can see that drawing the entire screen takes like a second. So it's a relatively slow process. So we want to avoid that. We want to update only things that are actually changing. And for this case, I will remove this line. What it does is it stops this middle lock panel, because thanks to this we will like get a better overview of what actually happens within the framework. And let's travel to the console manager. And now, instead of printing the actual volume, let's change that. Of course, coding on screen is always difficult, so but of course I made a small practice before that. Of course, this will not be the prettiest piece of code you've ever seen, but is the next, oh sorry, the next is a function, of course. 23. Okay, what it does is whenever we receive an update, it will not print the actual value, but it will randomly generate a single character. Thanks to this, we will see what actually gets updated on the screen, and maybe it will become clear after I actually build it and run it. So currently we can see actually by the background that everything stays the same. So we have this grid on the left and those panels here. But what is important is if you look at this whole screen, you can see that only this character here is actually updating. And unfortunately, it's a little bit fake. So this example doesn't say much because the console manager stores internally another buffer. So if it says that a character didn't change, it doesn't print it on the screen. And this is the piece of logic that actually handles this. But if we remove it as well, we can see that only the part within which, oh, maybe I should first, I didn't think about it. let's revert those changes. We'll go back to them in a moment. Yeah, so we can see that in the top right corner we have a clock, so it updates every second with a new time. But if we do this, so go back to our changes, we can see that the whole screen is not regenerated. The only thing that is regenerated is the content of this control. So not even the this control that hosts it, but just the text box that hosts the text with our current time, and only this part is being regenerated. And also, if I now start typing, we can see that this line gets changed because it's like a wrap panel with a text box and another text box. And whenever I type something within this text box, it thinks that, the whole thing actually resizes, so it has to recalculate itself. But this is the only part that changes, and the only part that actually has to be redrawn on the screen. So the change from this control is being propagated up, and then the console manager actually requests those controls to redraw themselves, but just within those boundaries. So it asks specifically for characters at specific positions on the screen. And of course, it doesn't ask it in, it doesn't provide them with exact coordinates of the screen, but in relative coordinates of each control. So that's easier to implement and easier to manage from the control perspective in this way. And also, if I type a text, you can see a card here traveling. It's almost at the end. And yeah, the whole thing now has to be redrawn because it's a huge stack panel and one of its components actually changed its size. So it has to actually recalculate the overall layout of itself, and everything here will change at this moment. But once again, if I have a new line, once again, it updates just itself whenever it keeps the same size. So that's like a big performance improvement, because only things that actually changed have to be recalculated. And we can also see this on this thing. So on the scroll bar, if I scroll, only the content of the thing actually changes, but the border, for example, does not have to be redrawn. Let's revert those changes, and maybe let's look at the code a little bit more. Let's start maybe with the eye control. So this is the interface that you have to implement whenever you want to define a custom control, or rather when you want to implement a fully custom control, because if you want to simply create a control out of other controls, there is a much simpler way to do it. But you can see also that this interface is very simple. So the control, all it has to do is to provide its size, because parent control has to know how much space should it reserve for this control, and when asked, provide a character at a given position. And the position is a position relative, so within the space of this control, not the general overall window. And another very important part here is the context. The context provides limits, so the size limits for this control, and it's actually set by its parent. There is an event that notifies a child that those limits have changed. And also there are two methods the child can call to notify the parent about its changes. So whenever there is an update on a child, it will call this update method with a rectangle. And then the parent will crop this rectangle based on what's actually visible on the screen. So if we have a huge scroll view and there is a huge space, a huge vertical space, and something updates out of the screen, the parent control, the scroll view control, can actually detect it and will not propagate this event even further. So if something is not visible, it will not trigger an update. And of course, if there is a bigger update that updates also the size of a control, then you have to actually call the redraw function, because yeah, it notifies the parent that it should actually try to redraw itself, because the layout, the general layout, might have changed. And if we look at the some simple example here, maybe a margin would be it. So we have a content, we have an offset that can be set by the user, and then whenever something else requests a character at a given position, we check if it's like within the content context, and if it is, we return this character from the content, and otherwise we return an empty character. And the content context is like a special class declared within this framework that allows us to like set the offset and limits for the child component. And then we don't have to worry ourselves about translating positions between the parent and the child. And also there are more advanced controls like the text box, which implement actually the input listener, and it's also very interesting interface and very simple one at the same time. It declares just one method on input, and when you implement it, you receive an input event. And what this input event is, it's simply whenever you hit a button on your keyboard, it's being propagated to the controls that are listening to it. And simply the text box actually acts based on this event. So whenever, for example, there is a left arrow, it moves the caret. Whenever there is, I don't know, backspace, it deletes something, and whenever there is a writable character, it simply puts it in a place of the caret. And the reason why it's designed in this way is because the text box, for example, might not be fully visible on the screen, or it might be like wrapped, like we saw in our example. And in those situations, we cannot simply depend on the standard handling of input by the console itself. So that's why it's implemented like fully customly, and that's why we have to like manually handle each keystroke ourselves and modify the underlying text within the control. And how do we actually notify this control about those events? So we need to have some kind of an main loop of an application, but I didn't want to impose it from the framework perspective, so I just leave the users choice on how to actually implement it, because it might be that they already have some kind of a main loop in their applications and they don't want to actually change it. So yeah, this is simply a main loop that you can define, a simple for loop, and then all you have to do is call the console manager read input, and the input that it provides is a list of input listeners, and those will be notified in this order about the changes that happen on the input. And that's it. So you don't have to do any other special processing. If there is a control that actually managed to handle the event, it can set the handled property of the input event. This is just a standard input event that you would receive normally from the console. And if you set the handled to true, it will no longer be propagated to the childs, to the other controls that are within this list. So it's very simple implementation here. We can see that, yeah, nothing fancy actually happens here. And I think, oh yeah, let's take a look at one more thing within the example. that is the how to define custom controls. And it's also very simple. Maybe let's look at the board. So within the board, we have a board cell. So each cell within the board is represented by an object of this class. And it's very simple. So we have like, we defined a cell, which is a simple eye control. First of all, the board cell has to inherit from the simple control. That will like take care of implementation of the eye control in the first place. So it will like provide all of the methods that are required here, and all we have to do is set the content, which is a protected property of the simple control, to something that we want to display on the screen. And yeah, that's it. So then we can use this this board cell as a simple thing that we want to display within other controls that would expect it as a child. And maybe let's take the final look at the application itself. So yeah, it's relatively simple. All you have to do is simply provide the layout that you want to display on the screen, and all else should be simply set. Oh yeah, I forgot about one thing, the input controller. Also a very important thing, so you can also implement from the input listener in other things than controls. So in this case, we defined an input controller which listens to the enter key. And whenever an enter key is pressed, it takes the text from the text box and simply pushes it into our lock panel, which is also a custom control defined just for this example. Very simple one. Also inherits from the simple controller, to which we can add multiple text lines. So first we have a timestamp, which is like in a different color. Then we have the text, all in a wrap panel, so that whenever it's like wider than the screen itself, it will wrap to the next line. And we add it to the stack panel, which is being displayed on the right. And that's it. So if you want to define custom controls, it's also very easy. If you have any questions about this framework, feel free to ask either here or on the GitHub. And if you want to take a look at the source code which I recommend, then yeah, I will leave the link to the GitHub page in the description of this video. Thank you guys for watching, and see you in the next video.